You're looking live at the Chapter 2 practice test review with me, your host, Mr. Goldman. Let's get started. Convert the following fraction into a decimal, 1/5. A lot of ways to do this. You could do 1/5 times the giant 1 of 20 over 20, which would give us 20 over 100. This makes sense because 20 over 100 is very easy to rewrite as a decimal of 0.20. We can also do the division, which works every time. Remember, all fractions are just division problems. And we divide in the order that we read, top to bottom. So this would be 1 divided by 5. So 1 goes in the house. 5 goes outside the house. 5 goes into 1 0 times. The decimal moves straight up. 5 goes into 10 twice. 2 times 5 is 10, remainder of 0. Since I get a remainder of 0, I know it terminates, and the decimal is 0.2. Or 0.2 or 0.20, any of those work. Question the second. Convert the following fraction into a decimal. There is an unnecessary picture of stuff up here. I don't know why. 1/9. Hopefully we remember from our patterns with 9 as the denominator that this is just going to be 0.1 repeating. But again, on your test, I want you to show me some work. So show me some long division for this. 9 goes into 1 0 times. 9 goes into 10 once. 1 times 9 is 9, remainder of 1. Bring down the 0, 9 goes into 10 once, and we now have the remainder has repeated, so I know that I have a repeating decimal, and it's just going to be 0.1 repeating. Question 3. 3/8. This is 3 divided by 8. 3 goes in the house. I'm going to do 3 decimal points just in case I need all 3. 8 goes outside. 8 goes into 3 0 times. Decimal place goes up. 8 goes into 33 times. 3 times 8 is 24. Remainder of 6. Bring down the 0. 8 goes into 67 times. 7 times 8 is 56. Remainder of 4. Bring down the 0. 8 goes into 45 times. 5 times 8 is 40. Remainder of 0. Since I have a remainder of 0, I know it terminates, and my decimal is 0.375. Again, you will need to show the work on the test. Here you will not need to show a lot of work. Convert the following decimal into a fraction. Well, this is 23 hundredths, 23 over 100. The trick here, how many numbers are behind the decimal? There's 2, so just put that number in the numerator, and then put a 1 with that many zeros as a denominator. There you go. Question 5, 0.023. So again, my numerator is just going to be 23 because 023 is just 23. But my denominator is now going to be a 1 with 1, 2, 3 zeros. So 23 thousandths. Using a lot of paper for this video, so hopefully it's for a good cause. All right, this one, a lot of questions on this one in class. This is 0.23 repeating, right? We would write this as 0.23 with a line. In 8th grade, you'll have to solve these using algebra, but here we just want to remember the pattern we discovered with the 9s. I have 23 is my numerator because that's the part that's repeating. And since there's 2 numbers that are repeating, my denominator is going to be 99, just 2 9s. If this was, say, 0.234 and all of that was repeating, then my numerator would be 234 over, there's 3 numbers repeating, so there would be 3 9s. Again, you're not really going to have to show any work for that standard. Standard 10, review standard. I can add fractions with unlike denominators, 1/5 plus 1/2. I'm going to show the full giant 1 stuff here. Let's see, multiply by some number, and we want to get a common denominator. My 2 denominators are 5 and 2. My common denominator is going to be 10. All right, just those 2 numbers multiplied together. Any common multiple is fine. And we're going to use this giant 1 template here. 5 times what number is 10? I'm going to put 2. And if 2 is in my denominator, my numerator is going to be 2.
Giant 1, yes.
Guest appearance. Miss Alsop, would you like to do a problem? Guest appearance?
No, I'm avoiding grading.
1 times 2 is 2. 1/5 is the same as 2/10. So I can rewrite this as 2/10 plus. Same process for 1/2. 2 times what is 10? 5. So 5 goes in the numerator also, and 1 times 5 is 5. And 1/2 is the same as 5/10. So instead of 1/5 plus 1/2, I have 2/10 plus 5/10, and that is 7/10. As far as showing work, you don't necessarily have to show all of this, but you do have to show this. If you're going to convert a fraction, show me the converted fraction. All right. Question 8, 2 3/7 plus 2/5. So first I'm going to rewrite this mixed number. Oh, actually I don't have. Okay, we'll do it two ways. I'm going to rewrite this mixed number as an improper fraction. So I do 7 times 2, which is 14, plus 3 is 17. So this equals 17/7 plus 2/5. My common denominator here is going to be 35 because 7 times 5 is 35. So let's do 17/7 times blank. And I have 2/5 times it, something over 35. So my giant one for 17/7 is going to be 5 over 5. And 17 times 5 is 85. My giant one for 2/5 is going to be 7 over 7. And 2 times 7 is 14. So I have 85 35ths plus 14 35ths. And I add those together. I'm going to add the numerators and keep the denominator at 35. So I'm going to get a 99 35ths. You can leave your answer just like that. Or we don't have to convert the 2, because 2 3/7 plus 2/5 is the same as 2 plus 3/7 plus 2/5. So then I can just convert 3/7 and 2/5 to a common denominator. 3/7, my giant one, would be 5 over 5. So it would be 15 35ths. And 2/5, we already know, is 14 35ths. So I have 2 plus 19 35ths, or 2 and 19 35ths. So both of those answers would work. 7/11 plus 2/3. My common denominator is going to be 33. 7/11 is the same as 21 33rds. 2/3 is the same as 22 33rds. I add those together, I get 43 33rds. You can leave that as your answer, or we can write this as 1 and 10 33rds. Both of those are fine. Problem 10. I can add positive and negative numbers. We can do these a lot of different ways. Here, I'll just go left to right. 50 plus 37 is the same as 50 plus negative 37 is the same as 50 minus 37. So this is the same as 13 plus 13, which is 26. We could have also done, sometimes I like to take all the positives and then the negatives, so I could do 50 plus 13. That's the commutative property because I'm changing the order, and get 63 minus 37, which is also 26. 19 negatives and 19 positives. When I add them together, those are all going to cancel out, and we're going to get 0. As far as work for this, you don't really have to show much. Yeah, depending on the problem. Here, I would like to show a little bit of a step. This one, you're not going to have to show work. All right. 45 plus negative 19 plus negative 27. We'll group this. We'll use the associative property and regroup. So I'm going to think of this as 45 plus, and then I have 19 negatives and plus 27 more negatives. So I'm just going to add 19 and 27, and that's going to be negative because I'm adding negatives. So that is going to be 9 plus 7 is 16. 2 plus 1 is 3, so 4, so we have negative 46. 45 positives and 46 negatives. All of the positives are going to cancel out with 45 negatives, and we're going to be left with 1 negative. Standard 12, I can multiply and negative integers. Multiply, oh, it says that right. I can multiply positive and negative numbers. All right. 3 times negative 7. I know this is going to be 3 groups of 7 negatives. So my answer is definitely going to be negative. A positive times a negative is always negative. 3 times 7 is 21. There you go. Question 14, negative 1 times negative 1 times negative 1. I'm going to use the associative property. I'm going to group these two first. Negative 1 times negative 1 is positive 1. So now I have positive 1 times negative 1, which is negative 1. Anytime you have an odd number of negatives that we're multiplying together, your answer is going to be negative. If we look at this next problem, anytime we have an even number of negatives, I'm going to group these two, again, using the associative property. Negative 3 times negative 4. A negative times a negative is a positive, so this is the same as 7 times 12, both positive. So our answer is 84. All right. Last standard, I can multiply mixed numbers. Remember, definitely convert these to improper fractions. It's not like the addition where we can do both. So we're going to convert 3 times 2 plus 2. So 3 times 2 is 6, plus 2 is 8. So we have 8 thirds. 3 times 3 is 9, plus 1 is 10, times 10 thirds. And this is 80 ninths. And we can leave it just like that. Or we can write 7 and 8 ninths. Remember, when we multiply numerator and denominator, right? It can be tricky if you have the same denominator when multiplying. People often forget to change it because when in addition, we do not change it. But in multiplication, multiply straight across top and bottom. All right, these next two are more challenging than the test problems will be. I promise you. I won't make numbers quite this big on the test. First thing, we're going to convert to improper fraction. 5 times 7 is 35, plus 2 is 37. So we have 37 fifths times 7 times 11 is 77, plus 1 is 78 sevenths. I think we all know that 37 times 78 is 2,886, and 5 times 7 is 35. Remember, no calculators on this test, so you would have to do any of this calculation by hand. So that is the answer. That's also equal to 82 and 16/35. Either one of these is fine. Remember, improper fractions are fantastic. Last question. Again, convert to improper fraction. 11 times 9 is 99, plus 2 is 101. 11ths times 8 times 21 is 168, plus 1 is 169 eighths. Notice I can't cross-simplify anything here, so I know I'm not going to have to simplify the product. And of course, 101 times 169 is 17,069. And 11 times 8 is 88. I know that that's simplified, again, because I couldn't simplify any of the fractions. Or we can write this as a mixed number as 193 and 85/88. Thank you for watching. Good luck tomorrow.